Hi guys, Naveen here. I am here to show about the voltage divider circuit. The voltage divider circuit is a very basic circuit in most electronics. A voltage divider circuit consists of an input voltage source and two resistors. Let me draw a simple voltage divider circuit. Suppose we have an input voltage V in, positive and negative. It is connected to two resistors in series. Let us name it as R1 and R2. The voltage we need to divide from this input voltage is taken from the junction of these two resistors as V0. Let us connect the other part to ground. Now, to calculate the voltage output from here, we can use Ohm's law. Ohm's law states that voltage is always equal to current into resistance in the circuit. In this series circuit, the current is always constant. So, the current is always constant. I, let us assume I is the current. Now, when we consider this as a separate circuit, still the current is same, but the resistance is different here. When we consider the whole circuit, the resistance is R1 plus R2. Now, in this entire circuit, the voltage supplied is V in. As per Ohm's law, this voltage will be equal to current I into the resistance values, the total resistance values of these two resistors, that is R1 plus R2. Since they are connected in series, the total resistance value will be the sum of the resistances. Now, from this we can derive the value of I, current. Current is equal to V in by R1 plus R2. Now, to calculate the voltage over here, we again use the Ohm's law, but to this time we limit it to the circuit containing only R2. That is, the voltage is measured from the junction between two resistors and the ground over the resistor 2. So, V naught is equal to current. The current is same in the entire circuit, I into resistance. The resistance in this circuit is only R2. Since we already know the value of I, we can substitute it here. I is V1 by R1 plus R2 into R2. That's it guys. This is the simple equation used to derive the output voltage inside a voltage divider circuit. Now let us take a practical example of this. I have a breadboard with me here. I have also a supply of 5 voltage. Now let us test the input voltage by setting multimeter to 20 volts. Let me clean off these resistors. Now let us connect both terminals of the voltmeter to the input source. It is around 5 volts. I think I connected it in the wrong direction. You should not do that as it will spoil the multimeter. Okay, the input voltage is approximately 5 volts. I have two resistors with me, a 1K resistor and a 2.2K resistor. Now, let me connect these two resistors in series. I am connecting the 1K resistor to the supply source. Let me invert the supplies. There is a positive 5 volt coming here and this is the ground of the supply. If you are not sure about the resistor values, you can always measure the resistance using the multimeter by setting it to resistance kilo ohms. Alright. Now, the resistors are connected in series to the input power supply. As per the diagram I explained before, as per this diagram, the voltage input is here, the resistance R1 is 1K, 1 kilo ohm, and resistance R2 is 2.2 kilo ohms. Now, No, there will be no voltage change across the entire circuit. It will still be the same 5 volt. Sorry. As you can see, the voltage is still 5 across the entire circuit. Now, applying the voltage divider principle, let us calculate the voltage between the junction of the resistors and the ground. V0 is equal to V in is 5 volt divided by resistance values. The one is 1K and the other one is 2.2K. We are measuring across R2 2.2K is equal to 5 by 3.2 into 2.2 is equal to approximately is equal to 3.43. Now, if Ohm's law is correct, we should get 3.43 in the voltmeter when I measure across the junction of the resistors and the ground. Okay, it is almost 3 volts. This is because the battery in the multimeter may be volt, it might not be supplying exactly 9 volt, or the resistor values may not be exactly 2.2 and 1K. There are many factors governing this, but what we infer from this is the voltage divider circuit works. The 5 volt is converted to 3 volt. This can be used in many applications such as potentiometers, variable resistors, tuning circuits, etc. etc. Thank you guys. Please like and subscribe the video. If you have any questions, please post in the comment section.